So starting with you, Amber, how can we find the measure of angles A and B?
Okay, well, because they're vertical, they're congruent, so
Yes.
you can set 4x plus 6 equal to 3x plus 24.
Yes. So we have the ability to set the angle measures equal to one another because they are vertical angles. Anytime you have two lines that intersect, the opposing angles are called vertical angles, and they are congruent. So please help me solve this algebraically.
Okay, well, you subtract 6 from 24, and then subtract 3x from 4x, so you get x equals 18.
X equals 18, and then?
And then you can just plug it into one of them, or you can plug it into both to check to make sure it works.
Correct.
So, and then I got both of them equal 78.
Okay, so plugging in 18 for x, we get 4 times 18 plus 6. 4 times 10 is 40, 4 times 8 is 32, 40 plus 32 is 72, 72 plus 6 is 78, and Amber's reasoning is valid. These are congruent, therefore technically we don't need to plug it in for the other one, but you can do so if you want to check. 3 times 18, 3 times 10 is 30, 3 times 8 is 24, 30 and 24 is 54, 54 and 24, 78. Okay? Yes? Sorry about that. Check to see if there's another one. Okay. Julia, how can we find the unknown angles in this triangle?
They all add up to 180.
Yes.
So you do 2x plus x plus 18 plus x plus 106 equals 180.
So I assume that you all know that angles in a triangle add up to 180. Therefore, you can use that to add these three angles. Make an equation. So 2x plus x plus 18 plus x plus 106 equals 180.
And you get 4x equals 57.
Thanks. 4x plus 124 equals 180. 4x 56 and x equals 14.
And then you plug the 14 back into the separate equations.
Good.
28.
2 times 14 is 28. That's one of our angles.
32.
14 plus 18 is 32. And 14 plus 106, 120. Okay, just stop me if you have any questions. Okay, Jen, how will we figure out the measures of angles A and B in number 3?
For number 3. Okay, so we know that those two are congruent
And why?
because they're alternate interior.
Very good. They are alternate interior, therefore they are congruent. Please continue.
So you would set them equal to 180.
So, say again.
You would set them equal to 180.
Now, if they're congruent, that means they're
You
equivalent.
set them to each other, sorry.
Correct.
Yeah.
If they're supplementary, you would set them.
Yeah.
You would set the sum of them equal to 180.
Yeah. And then you would subtract the 9.
Mhm.
So it's 5x equals 4x minus,
Plus
oh, sorry, plus 7.
7.
And then you subtract the 4x.
Good.
You both sides. Yeah, 1x equals 7. And then this one doesn't. But then you have to plug it in.
Very good.
So you would do 7 times 5
Mhm.
plus 9.
Mhm.
And oh, wait, 1 second.
So
Yeah, I didn't actually have to do that. 44. And
44.
that's for both of them because they are congruent.
Nice. Okay. Brett, how will we find the angles A and B in number 4?
They're congruent because they're alternate exterior.
Very good.
So you set them equal to each other.
Good.
We get x equals 27 degrees, and you plug in 27 for each equation, or for just one of them, you get the angle is 145 degrees.
Okay. So when we solve this algebraically, a minus 5 is 3, 27, as Brett said, and then we can just plug it into one of them. 3 times 27 plus 54. That's 60 and 21, which is 81, plus 54, and that's 135. And because they're congruent, we don't need to find the other. Okay. Next up, Nikki S. How will we find angles A and B in number 5?
We can do 4x plus 7 plus 3x plus 89 equals 180.
Good. These are supplementary angles. They're called same side interior. So we can sum them up to 180. And continue.
Then you add the x's and you get 7x.
Mm-hmm.
Plus 96 equals 180.
Mm-hmm.
And you subtract the 96 from 180.
Mm-hmm.
And you get 7x equals 84.
84.
And divide by 7.
Mm-hmm. Good.
And then we plug it back in.
Nice.
Get 4 times 12 plus 7 equals 55.
Mm-hmm.
And for the other one, you get 125.
And as a check, look at the angles, see if they add up to 180. They do. Nice. Well communicated. Next, 6. We're given 2 angles, 30 degrees, 24 minutes, and 67 degrees, 22 minutes, and we want to find if, we want to find the measure of the third angle. Did you have a question? Dominique? Okay. So, Chowan, how can we find this out? Okay, let's add them first. 30 degrees, 24 minutes, and 67 degrees, 22 minutes. So what do you get? 97 degrees, 46 minutes. And then? Okay. So since the angles in a triangle add up to 180, to find the remaining angle, we can do 180 minus the sum of the other two. And what Chowan did, since her first angle measure did not have a minutes measure that was higher than the second one, she borrowed a degree. She made it 179 degrees, 60 minutes, since there are 60 minutes in 1 degree. Please continue. So 60 minus 46 is 14. And then 2, we can make this 17. So 8. Yeah. So it looks like 82 degrees, 14 minutes.
Let's say 60 seconds.
60 seconds?
Would you have to say it?
No.
No, you don't have
I'm just wondering why you're thinking.
to. Oh, I
You might.
I thought that you would just like have to like, so, when there's minutes, there's seconds.
Oh, okay. No, it's not necessary.
Okay.
Yeah. Okay, Val. Triangle classification.
I said that it was equilateral.
Acute and equilateral. Good.
Because an equilateral triangle can never be obtuse.
Correct. Yep. So there's two ways to classify triangles because there's two characteristics or two properties with regards to triangles, angles and sides. So you can have an acute triangle angles less than 90 degrees. You can have an obtuse triangle. In which you have one angle greater than 90 degrees. You can't have multiple angles greater than 90 degrees because the angles have to add up to 180. You can have a right triangle in which one angle equals 90 degrees. And that's it. For the sides, your classifications are scalene, in which no two sides are congruent. Isosceles and isosceles. When I'm trying to spell it, I say to myself isosceles because I often forget that second S. This is where two sides are congruent. By the way, this comes from the Greek for same sides or same legs. And then equilateral. The arch in St. Louis is an extruded equilateral triangle. Equa for equal. Lateral means what? Yeah. Like latissimus dorsi. Okay, when you're doing lateral movement, side to side movement. Equilateral triangles are also equa.
Distant.
Angular. Yep. Great, so those are our options. Okay, Dominique, triangle number 8. Acute and isosceles. Yeah, these marks here help to indicate what sides are congruent. So single mark is going to be congruent with the other single mark. This one is not congruent to either of those. So it's isosceles, and all the angles are less than 90 degrees. Good. Terry, triangle number 9. D, right and scalene. You got a right angle. All three sides are different. Good. Nick, number 10. Good. You have an obtuse angle, an angle greater than 90 degrees, and all three sides are different. Jessica, number 11. C, obtuse and scalene. I agree. Gabe, number 12.
Both isosceles, obtuse.
Isosceles and obtuse. Good. And Yunjae, number 13. Right, isosceles, good. And Nakia. Oh, now we're on a new section. So Nakia, do you know anything about similar triangles? Okay, I will take a guess. If it has two lines, it's the same as the other one having two lines? Yeah, I'm not sure I follow. Oh, okay. So well, first of all, B and S are angles. And your belief that they're the same is true. So we're getting somewhere. So similar triangles, Nakia, the corresponding angles are congruent. But what do you think? Yeah. One could be bigger than the other one, but they're still similar because they have the same shape. And like the angles, the corresponding angles are all the same. Okay, so just to review. Similar triangles have corresponding angles that are congruent. And their corresponding sides are what? Say it out loud. What's that? Not necessarily. Proportional.
Well, that's what I was looking for.
Okay. Sorry, corresponding sides. Similar triangles are handy. So, back to number 14, Nakia. Correct. Angle A corresponds to angle R. Sue, number 15. Angle B corresponds to angle T. Nikki Brown, number 16.
D, angle C corresponds to angle R.
Good. Angle C corresponds to angle R. Celine, number 17. B. Yeah, angle B corresponds with angle T. Dan, side BC corresponds to ST. Good. Amber, 19, side AC corresponds to
BRS.
side RS. Good. Julia, number 20, side BA corresponds to AST. Jen, AC in 21 corresponds to?
ST.
I don't think so.
21.
Oh, 21. I heard we were on 40, sorry. It's RS.
RS. Yeah. Brett, and 22, AC.
AC corresponds to D, it can't be determined.
I think it can.
EC?
EC. That's what I believe. Okay. How? Well, maybe we can figure it out. This is congruent to this because they're vertical angles. AB is parallel to DE. So let's see. I'll use pencil in case I need to erase. This angle here is going to be congruent to this angle here. Do you see that? Transversal, two parallel lines, alternate interior. And then this angle here will be congruent to this angle here. Okay? So side AC is the one opposite this angle with the two arcs, which is opposite this. And I'm really glad you asked that question because that allowed me to prove it to myself. Okay? Next, Nikki S, 23, side, angle U.
I said C.
R. I'm going to go with S. Does anyone agree with me?
I do.
Okay. Yeah, this one here, I'm going to say is corresponding to this one here. Okay, now we're going to put the triangle similarity to work. We're told that the triangles are similar, and we need to find a missing side, angle, or value of a variable. So we're told that that's 41, that's 40, that's 9, this is 82, this is 80. Okay. So we want to find x. Choan, how can we set up an equation here? Or use our knowledge of similar triangles? Okay, and y times 2? Yeah. Remember, similar triangles are proportional, or their corresponding sides are proportional. So this base corresponds with this base. Notice that for the bigger triangle, it's 2 times this. Therefore, the other sides are going to follow that same pattern. The hypotenuse here, double it, you get that. And then the height here, double that, you get 18. If you didn't notice that, no big deal. You can set up a proportion. We could do big base to small base. 80 is to 40. As big height is to small height. That's one option for a proportion. Cross multiply, or just multiply both sides by 9. What's 80 divided by 40, anyone? 2. So it's just 9 times 2. 18. Good. Okay, 25. Let me just label these. 12, 15, 6, 4, 5. Okay, Val, how can I find x in 25? Proportion, yeah.
No, wait, it's like 3.
Yes, the larger triangle is just 3 times the size of the smaller triangle.
Yeah, so then it would just be 6 times 3.
Very good. Okay, 26. Let me label it. Okay, Dominique, how can we solve this one? Yes? So, because these are similar triangles, the corresponding sides are proportional. So you can set up a proportion. Oh, I'm sorry. It's hard to hear you sometimes.
So I did 20 over 60 equals 34.
Now, I wouldn't do that. You have to stay consistent with your ratios. So if you're going to do, okay, yeah. So big left side over small left side, big base over small base. Okay. And then to make the math easier, Dominique, what's 20/16? There you go.
5/4.
Nice. And then we'll multiply both sides by 32. Tell me, what's 32 divided by 4? 32 divided by 4? 8. And 8 times 5? 40. Okay? Next, 27. First, let me label it B. B is 8. And we want to find angle Q. Terry, angle Q is? Same. Extremely simple. It requires you, however, to know that similar triangles have congruent corresponding angles. It has to do with the arc. That's the methodology that will be used. Yeah. In this case, not needed. Okay, next we are given that this is 61. We want to find this. So Nick, 28. Yeah, easy. You can think of this triangle here as rotating to become there, and then this angle here becomes that one there. Okay, next. Jessica, number 29. B. Easy. Next, number 30. Let's label 57, 35. Gabe, how will we find the measure of angle C?
Have to get a 57, 35.
Mm-hmm.
Subtract that. 180.
Good. And what do you get?
Get 90. Oh, 92.
So it'll be 180 minus 92.
Yeah.
180 minus 90 is 90.
So 88.
Minus 2 is 88. Yep. Good. Next, we're given the measure of angle A in 31. It's 46. We want to find this one here. You and Jay, can you guide me through the process? Mm-hmm. So this is 46, angle X. Mm-hmm. Yes, so to state what he said, or to paraphrase, since angles in a triangle add up to 180 degrees, and since you know two of them, to find the third angle, you simply subtract the sum of the two known ones from 180. $136. So 44